course, there's been a lot of change, but one of the significant changes is the demand for power. That's something that if you go back 30 years ago, we didn't see the demand. And it's not just for any power. We're seeing the demand for, well, the traditional, reliable, safe, and affordable power. Even more importantly, resilient power. It used to be utilities would use average metrics to drive their actions. But what we're seeing is that those average metrics obfuscate, they hide the challenges that we're facing. You think about from a challenge standpoint with a lot of the distributed energy, with the greater demand and the need for resilient power in our lives. We use power to cook, keep our homes cool, to, in some cases, drive our cars, certainly for AI functions and so forth, and huge demand for energy for data centers. But then we have aging infrastructure. We're operating with our grandfather's grid here. This grid is not only aging, but it was built for a different era. And now even the average storm that comes through creates chaos with a lot of our networks. And of course, that has a big overhead component. We're going to be talking about cable systems. That's part of the solution, but we also have to be thinking about the total cost of ownership. When we think about the total cost of ownership, we think about what does it cost to operate the grid, and then what's the challenge to maintain it over time. We've got a population that is ever increasing on high-risk areas and geography. We have 30% of the U.S. living along the first county along the coast. We have more people moving into the wildland urban interface. We have more people living in floodplains. We have higher risk, bigger demand, and aging infrastructure. That's not a good mix for resilience, right? So I really think one of the biggest challenges and the changes we need to make is we need to be thinking about total cost of ownership of assets. And it's really no different with cables. I think cables, we really need to be thinking about the total cost of ownership and how do we extend the life of these assets so that these systems can last 50, 60, 100 years instead of the typical, what people used to claim, 20 to 30 years.